We've got ourselves two lines. So this is L1, line number 1. This is L2. They meet PT and S on the x-axis there. So that's for a quick read. So the straight line L1 shown in figure 1 has equation 5y equals 4x plus 10. I'm just going to go ahead and divide through by 5 here and get y equals 4/5 x plus 2, just to put that in the form of y equals mx plus c. It might not be helpful, but I'm going to think that it is. The point P has x coordinate 5 lies on L1, so this is P, that has x coordinate 5, so 5 is around about there. Find an equation for L2, write your answer in the form ax plus by plus c is 0, where a, b and c are integers. Right, so up here we have the equation y equals mx plus c, so m1 is 4/5, we can see that. There's our m1, so I'll denote this m1 just to kind of relate this to the gradient for the line 1. So the gradient for line 2 is minus 5/4. So if you remember, these two are negative reciprocals. In other words, if we multiply these two together, we get -1. And all we need to find the equation of a line from this point is the gradient and a coordinate. We have an x coordinate of 5 here, so I'm going to take this equation up here, this y equals, sorry, I didn't show you that. So y equals 4/5 x plus 2. If I substitute x equals 5 in there, let's have a look what we get. We get 4/5 of 5, which is 4, and 2, which is 6. So we've got a gradient up here of minus 5/4, 5/4, and a set of coordinates of 5, 6. Alright, so I'm going to use the equation of a straight line. You can use y equals mx plus c, or y minus y1, which I'm going to use, equals mx minus x1. The reason I'm using this mainly is because once it's in this form, and this is, I think it's just a bit quicker because it just falls out quite nicely, as you'll see. So let's put everything in. We get y minus 6, the 6 here, okay, which is equal to minus 5/4, given by this here, minus 5/4, oops, x minus 5. So the information is a bit all over the place, but it works, okay. So I'm going to get rid of this fraction. I'm going to times it all through by 4. Let me just come over here. So I've got 4y minus 24, times it all by 4, equals minus 5x, minus 5 times minus 5, 2 negatives, positives. So we get this. And now all we've got to do is got to make sure it's in the form ax plus by plus c is 0. So I'm going to add 5x and subtract 25, and I think we're going to get 5x plus 4y minus 49 equals 0. So I'm just going to list A, B and C there just so we can see them. Alright. So at this point that's it done, really. We found our equation of a straight line. So for part B, it says here the lines L1 and L2 cut the x-axis at the points S and T respectively. So ST. Calculate the area of triangle SPT. Alright, I'm going to do most of the work on the diagram this time. So to find the y coordinate, no, not the y coordinate, sorry, the x coordinate of S, what we're going to do is we're going to put y equals 0 into this, or this, it doesn't matter which one. I'm actually going to put it in this one, I just think it's a little bit easier. So at y equals 0, we get 4x equals -10. Just subtracting that 10, therefore x equals minus 5/2. Just dividing it by 5, so I'm just going to put that on there. So we've got the minus 5/2, 0. That was for line 1. Now for line 2, I'm going to come down here and I'm going to use this one. I'm going to do the same thing. I'm going to substitute in there y equals 0 because we're still on the x-axis. So at t we have y equals 0, so 5x equals 49 from this, just putting y equals 0 into here, taking them away, so adding I suppose, therefore x equals 49 over 5. So over here we have the coordinate 49 over 5, 0, and we already know this one is 5, 6. Okay, so what we've got to do is calculate the area of the triangle, which isn't too bad. Numbers are a little bit nasty, but we can figure it out. So what I'll do is I'll draw it down here, I think. So roughly, well, this one's easy. The height is quite easy. If you remember, P had the coordinate 5, 6. That's 5 along, 6 up. So the height is fairly just straightforward of a 6. But the base would be these two x coordinates. So the difference from, let's say this was our origin here. This bit was 49 over 5. This bit had a length of 5 over 2. So I know then from the coordinates, and I know that was negative 5 over 2, but as a length, it's positive. So what I'm going to do is I'm going to do 49 over 5, add 5 over 2, which is 98 over 10, plus 25 over 10, which is 123 over 10. Oh, I don't know why I wrote 6. 123 over 10. So the area of this triangle over here, I'll do it over here, so the area is half times 6 times 123 over 10. Half of 6 is 3, and 3 times 123 is 369, so I think the area of this triangle is 369 divided by 10. We don't have any units, so I suppose we could just write square units, but it doesn't really matter too much. So there's our area.